create the program for the defining the DNA Hamming difference project. So I'm right now in your classwork section where the instructions for the project is present. What you need to do is you need to open Replit, which I already have opened because that's where you will be creating your project. And you also need to open up the instructions file, which is this one here that says Hamming difference strands. And there are other resources that will be useful for you. That is the planning document, the use of dictionaries, and etc. So the main objective of this program is just to find the Hamming difference, which means when there is a difference in the basis of the DNA strands. And so what I mean by basis is this A, G, C, T. So there are basically just four bases in the DNA strand, which can either be A, G, C, or T. So when you ask the user to enter at least a minimum of two DNA strands, you need to compare the bases in each DNA strand and see if they're the same. So if they're the same, for example, like this one, A is the same as A. So let's say this is a first strand. Okay, so this is strand one, DNA strand one. And let's say this is a second strand that the user is going to enter. So this is DNA strand two. Then you would need to compare, your program would need to compare each base in a strand. And maybe these two DNA strands are from the same ancestor. So, like, they're related, but they're taking, the DNA has been extracted or taken from time. So, the point is, you're trying to create a program that can identify where there's a difference in the base. So, for example, there's a difference already here because in the first strand we have a G, and in the second we have a C. We don't have the same strands, which should be normal since they're from the same generation. So the bases are supposed to be the same, but if they're not the same, then it tells us that some sort of mutation has happened. So here G is C, so it's not the same. So your program is supposed to find out all of the bases that are not the same and kind of like add +1 anytime it finds out that the bases are not the same. So for example, these ones, G, C, they're not the same. G is not the same as the C. So this is one Hamming difference. A and A are the same, so this is not a Hamming difference. Then G and T are not the same. This is a second Hamming difference. And then your program continues to compare it. C and C are the same, so there is no Hamming difference there. C and G are not the same, so there's another Hamming difference. So this is going to go comparing all of the strands up till the very end, which is the TT that we have here. Now remember that anytime there is a Hamming difference found, which you can see with this red arrows, your program is supposed to add it up. So in the end, for this particular two DNA strands that have been entered, the total number of Hamming difference will be a total of 3, 5, 7. So it will be 7 because you count 1, 2, 3, 4, 5, 6, 7. So 7 will be the Hamming difference. Now this is the general objective of the program, and this is what your program is supposed to be doing generally. But of course, I did mention that you have to also include an extension, some sort of extensive feature that might be useful for the biologist to use when using your program. So after finding the Hamming difference of the DNA strands that the biologist enters, perhaps you can add an extensive feature to basically find out if there is a Hamming difference, where exactly is the Hamming difference in the strands? Like, what is the location? For example, the location here starts with 0, 0. So remember, the computer starts to compare at 0, 0, and then goes all the way to 1, and then to 2, and so on. So you can do an extensive feature that actually points out where the Hamming difference has occurred, or you can do something else, but you need to have an extensive feature. Sorry about that. So once you get to the REPL to start creating the program, just click on create REPL. I'm going to call this, here you have to select the program type. So I'm going to do Python, a simple Python. Here, the name, I'm just going to call it form 4 Hamming difference example, so that I just show you how you get started. And once you click on create, it's going to generate the program or generate a blank file, as you guys can see. So you start here with writing finding, so give it a title like finding the Hamming difference. And then the first thing you're going to do is you need to have at least two DNA strands that have been entered by the user. And these DNA strands have to be the same length so you can make a comparison. So you can create one that says DNA strand 1, a variable called DNA strand 1, and this is going to ask the user to enter the first DNA strand. So I'm going to do it this way and say enter the first DNA strand. um, of a particular length. Okay. And I'm just gonna copy this code line and just put it in the second part, or in the third line here, because I'm gonna ask for a second strand. At least you should have at least allow them to enter two strands minimum. Normally, the best way I would say you should do this is to have a for loop. First, you ask them how many DNA strands they want to enter, and perhaps you can use a for loop to repeat asking them to enter the DNA strand so you can compare. I mean, that could be an effective way. So here we're going to say enter the second DNA strand for of a particular length. And then, sorry about that. And then the next thing you're going to do is once you come down here, you're going to want to compare the DNA strands so that you can find out. Well, first, you're going to want to check making sure that the DNA strands that the user is entering is of the same length. So you can call a variable like DNA length check, and then pretty much what this is going to do is that it's going to check the length of the DNA strands that the users have entered, making sure that the length is the same. You use a len function to do that, to check the length of each strand. So I'm going to do DNA strand 1, and then I'm going to do a DNA length check 2. Since there are two DNA strands, remember that it is more logical to ask the user to enter the number of DNA strands they want to find Hamming difference for, because that will make things much more easier and more efficient in your program. So this is just an example. So once you find the length of the two DNA strands, I'm going to call this DNA length check 2, and then this one is DNA length check 1. And then it's checking the length of the first DNA strand, checking the length of the second. Now we're going to compare and see if the lengths are the same. So we're going to use an if statement. So we're going to say if DNA strand length check is equal to DNA length check 2, then if they're the same, we come down here and we say print. We could print a message saying the DNA's match. I mean, the DNA strands match, okay? Length, or we can say the length of the DNA strands match. That will be much better to use than saying the DNA strands match. So the length of the DNA strands match. And then you could say we will now begin finding the Hamming difference. Hamming difference between the two strands, or you can say more than two if they entered more than two. And in the next line, this is where you start to find the difference. Well, to compare the bases in the strands and see if there's a Hamming difference. So you can create a variable called Hamming difference, and this variable should initially be set to a 0. And this variable will increase by 1 anytime a Hamming difference is detected. So to compare the bases of the two DNA strands, you need a for loop. So I'm going to say for x in range, and it will start from 0 to the length of the DNA strand. So you can choose any length as long as they're the same, so it doesn't matter. So I'm going to use DNA length. So what you're doing here is you're using a for loop to repeat comparing the bases of the DNA, which you're going to see in a few minutes, which starts at a 0 index position. Remember, the computer always starts at a 0 index position all the way to the maximum length of the DNA strands the users have entered. Now, once that is done, you put the colon, you come down here, and then you pretty much just start the comparison. So you're going to do if the DNA strand, which is this one, DNA strand, so it's better to use the DNA strand 1 variable because you're comparing the bases in the DNA strand. So use a square bracket here since it's a string. Oh, it's not a length. It's not a list, guys. So because it's a string, you're going to use, you can also use square brackets since it's a string as well. So you're going to say if DNA strand x, we're going to leave it as x since x is supposed to start from a 0 all the way to the length of the DNA. We're just going to leave it as x so that it starts like 0, then 1, then 2, all the way to the maximum length of the DNA strand. So we're going to compare by saying if DNA strand 1x, which starts at a 0, which means the first base in DNA strand 1, is equal to the DNA strand 2, which also is x, so which also is at position x. So which means we're comparing with themselves with the x variable, since it's going to be starting at a 0, the first base, and then it's going to compare throughout all the other base. So if they're the same, or we can rather say if they're not the same, because we're trying to find the Hamming difference. So this means not equal to, they're not the same. Then we're going to do this Hamming difference, which is equal to Hamming difference plus 1. And then, so this is going to help us find the Hamming difference. Every time there is a difference in the base, it will add plus 1. And then finally, we will print the results. So we're going to print the number, the final amount of Hamming difference. So we print it outside of the if statement, outside on the same line as the for, because we want it until it finished checking. And then it will print a statement saying the Hamming difference found is, and then we'll just pretty much call this variable, which is the Hamming difference, with an underscore, and then it should just display what was the total amount of difference in bases was found between the DNA strands. Now, if we run this program, let's just quickly run it. It tells me, you notice that it's telling me to enter a DNA strand, so let's check and see if everything works. If not, we can fix anything. So I'm just going to enter this one here, and I'll just copy it. And then I'll just paste it. Hopefully I can. I think I'm just going to have to write it down. I can't copy paste it. So GAG, and then we have CCT, ACT, CCT, ACT. And then we have, so I'm writing the first strand, AAC, GGG, AAC, GGG. And then we have AT. So AT. And then the second one, it says enter the second one. So the second one is this one. So it's CAT, CGT. So CAT, CGT. And then we have AAT, GAC. So AAT, GAC. And then we have GGCCT. So GGCCT. All right, so I think now we've entered the DNA strands that are the same. And I forgot to mention here, we forgot if the DNA strands are not equal, because remember we're comparing the length, and if they're not equal, there should be an else statement here. So please make sure you include it. So else, it should be saying something like print DNA strands are not equal, and it should repeat the program again. So this is why it's useful for you to have a function. So the DNA strands are not equal. Are not equal. So just that. So this is just to complete the if statement that I had at the top there. So now we're going to come back here, and it says enter the second DNA strand. So I think I've already entered it, sort of. It kind of disappeared. So GAT, we're in the AAT, TAA, TGAC. So TGAC. And then we're in the GGCCT. I thought I entered this one, so apparently it seems I did not. So GGCCT. And now let's hit an enter. Oops, I think I need to enter it again because I made changes to the program. So I'm going to run it one more time. So again, I will go. I'm just going to write a simpler, shorter base. ATCGATA. And I'll just write one that is like CA and then G, C, and then T, T, and then CCG. And then you guys notice that now my program actually gives me the length of the DNA saying that they have matched. And they will now begin the comparison of the Hamming difference. And it finds the Hamming difference to be 5. So let's check. There is the first Hamming difference here since there's G and C, so they're not the same. So that's Hamming difference number 1. A and A are the same on the second part. That is on index position 1, so there's no Hamming difference. T and G are also not the same, so that's the second Hamming difference. C and C are the same, so no Hamming difference. G and T are not the same, so there's a third Hamming difference. Then T and T are the same, so there's no Hamming difference. A and C are not the same, so there's another Hamming, that's the fourth one. A and C again, in the second to the last, they're not the same, so that's the fifth one. And G are the same, so no Hamming difference. So in total, we have 5, we have detected 5 Hamming difference, a total of 5 Hamming difference between these two strands of DNA. So this is a simple way of how to like create a program objectively, but you have to modify it and you don't have to do the same thing I've done. you should figure out a different way. This was only a video to help you understand what to do.